Okay, so this is 5.1 to 5.4, examples from the chapter review. So 5.1 is just saying galvanic cell, and draw a diagram. I'll do question 4, for example. So you've got Cl2 and lead solid, that's a gas, goes to 2Cl minus as a gas, and Pb2 plus aqueous. Okay, so it's already telling us the directions. So if I'm drawing my galvanic cell, the first thing I want to draw is my 2 beakers. Jimmy, you can see this okay. And then I'm going to have my salt bridge. I'm going to have my electrodes, which are going to be, in this case, one of them is going to be metal, and the other one will be platinum with a special gas, like metal bit. I know it looks terrible, but that's okay. I'm going to have a solution in each. Okay. Now, so we've got lead solid, Pb solid, and we've got lead 2 plus solution, and we've got chloride as a gas. I should put chloride there, shouldn't I? So you've got Cl2 as a gas in here, Cl minus aqueous, and this can be platinum is my electrode. So the reason that I have platinum, can you even see that? It looks really small. Turn it this way a bit. Anyway, the reason that we have platinum as an electrode is because chloride, if we can see here, is a gas to, that should be aqueous, sorry, to aqueous. So there's no solid. So if it involves gas and aqueous, we've got to draw our ridiculous Dalek tube thing. Okay, cool. Next, we've got to make sure we have our connecting wire. So that's electrons, and we've got to pick our salt bridge. So I'm going to pick sodium chloride, because I just think that's easy. Sodium plus. Maybe not chloride, we've already got chloride. Let's do nitrate. Nice and simple. Okay, and that's a minus. So, first thing we need to work out is what are our half equations. So we've got Pb solid goes to Pb2 plus. Looking at this as a basic thing, I know that I have to add 2 electrons to make it equal. So 0, 2 plus 2 minus 0, that's aqueous. So this one, we've got electrons on this side, which is the right side, so it's losing electrons. So we know this is oxidation. Therefore, it must be the anode. So this is negative for the anode. On this side, we have Cl2 as a gas, goes to 2Cl minus aqueous. And again, I'm thinking about where my electrons are going to be, and I might redraw it because I didn't leave enough room because I'm silly. So plus 2E negative goes to 2Cl minus aqueous. And you can see you've got 2 negative on that side and 2 negative on that side. Again, we've got electrons on the left, therefore it's gaining electrons, so that's reduction. An oil rig cat, reduction is gain at the cathode, so that means cathode is positive. So this is the cathode. Okay, and I think about my direction of electron flow. In this case, my electrons are going to flow from anode to cathode, because that's always true. So anode to cathode is my direction of my E negative. And then the last step is trying to figure out how to draw the direction of these ones, and also what's happening with my salt bridge. So you've got, it tells us in the equation, solid lead goes to aqueous, so that means that this one is starting to dissolve. I'm going to draw an arrow. And then you've got chloride gas, which is being pumped in, goes to chloride aqueous. So I'm just going to draw an arrow for that one. Okay, so we've got our 2 directions. And then lastly is the salt bridge. So in this case, you've got to think the positive cation goes to the positive cathode, and the negative anion goes to the anode. So basically the Na goes this way to join up with the Cl, so you're getting NaCl forming over here, and the nitrate goes this way to join up with the Pb. So you're forming PbNO3 aqueous, and you're forming, again, that's not essential. Like you don't. So that is a diagram with all the different arrows. It's quite a lot, but that's something that you guys should have practiced and should be feeling fairly confident in. That took me about 5 minutes of trying to explain everything, so hopefully when you've had a bit of practice, you can do it in 3 or 4 minutes, and that would be like a 10-mark question or an 8-mark question on a SAC. So difficult, but not too tricky. So that's 5.1, kind of. I'm going to rub that off now, and then we'll have 5.2. So 5.2 is looking at the electrochemical series. You've already seen that in your data booklets and in your questions and that kind of thing. So again, just picking a random one. A lot of them are kind of, yeah, just a bit tricky. It's not easy to show on the whiteboard. Let's try question 9 in the chapter 5 review. So you've got each of the cells combined to form a galvanic cell. Draw a diagram and then show everything. So I'm not going to draw the diagram, but I'm going to look at the 2 cells and see what happens. So silver, Ag, and zinc 2 plus and zinc solid. So that's the first one. Okay, so we look at our electrochemical series. We know that Ag plus is at the top, and zinc is way down at the bottom. Okay, so then imagine this is my giant electrochemical series, and I've got to think, okay, I'm making a backwards Z, so I'm using my good old backwards Z to figure out if it's going to work. So what I have is, this is aqueous, by the way, sorry, starting ingredient, and so it's this one. And there's my backwards Z, so it tells me which way everything's going. So silver aqueous is going to silver solid, and zinc solid is going to zinc aqueous. Okay, so that's the first example. And then I would obviously draw that in my other examples with my 2 beakers and my anode and cathode and all the arrows and my salt bridge and all that kind of stuff. I'll do one more just to make sure it's a little bit clearer. Again, I want to make sure it's one I definitely know, so I'm going to check this one. So it's copper 2 plus, copper solid, and nickel 2 plus, nickel solid. So I know that copper's above it and nickel's below. So copper 2 plus plus 2e negative goes backwards and forwards to copper solid. That's aqueous, obviously. And nickel, oh dear, nickel 2 plus aqueous plus 2e negative goes backwards and forwards to nickel solid. Again, so I'm thinking about my backwards Z. So I've got nickel as the start of my backwards Z and copper 2 plus. This one goes forward, this one goes backwards, and there's the lovely backwards Z shape. So we know nickel solid starts off and goes to nickel aqueous and copper blah blah. So it's just saying that if you drew your thing with the beakers and all the stuff, you could label everything and figure out what's positive, what's negative, etc., etc. So that's 5.2, or most of it. Some of them get a little bit more complicated, but I think that's why you have to put the work in and keep doing the homework. These are just going through the basics. So 5.3 is predicting periodic reactions. So this is 5.3. Again, I'm just trying to find a nice one that's not too complicated that I can show everyone. None of them are that helpful. Okay, so we might do question 12, for example. So in this case, you've got copper 2. Oh, why did I pick green? That was dumb, wasn't it? We're going with 9 minutes, so I'll finish off pretty quick, because again, long videos are boring videos. So you've got copper 2 in and Al solid. Basically, if you use an aluminium can and copper, is that going to react? So copper's up here, aluminium solid is down there. In this case, it will actually react because you have the backwards Z. So you can't store copper in aluminium because it will start basically breaking down the can. Who knew? Another example is sodium chloride. So Cl negative, because sodium also or Na plus in copper and copper solid. So I know copper solid is in, and Na plus is down the bottom, and Cl negative is there. There we go. So I'll draw the whole thing so everyone can see what I'm talking about. Okay, so the three ingredients we're given is chloride, aqueous, copper solid, and Na plus. So none of these will make a backward Z. So if we have copper solid, what we need to have is chloride gas, and that would make our backward Z. But because these two are on the same side, no backward Z, and because this is a forward Z, it doesn't work. Okay, so regardless, it doesn't work. So that's a no. Oh, so tick, cross. And the last example in 5.3 is... that's kind of a bit boring, isn't it? I've kind of done that. Okay, let's do it. So silver, Ag plus, and zinc solid. So again, we've got Ag at the top, zinc solid at the bottom. Again, we can form our backward Z. Easy. And you get the gist. So that's kind of the simplified version of a question. One's out there, but hopefully you can figure it out as part of the course. Bar, the shop soon, is there's not a lot of maths in this, so I guess a lot of that is just practice. Yeah. I think I think we'll just leave that there. Cool. Maybe I'll write the word practice. Worst part of chem. Sad face. Cool. Thanks, guys.